Hello everyone, welcome to 716 Day 2. Today we're going to be focusing on how to use the unit circle. So yesterday we spent the entire lesson just building the unit circle. So we took a position on the unit circle, like the position at 30 degrees. We took the angle of rotation and converted it to its radian form, and then we also found the x and y coordinates for that point on the unit circle, and we did this for each position on the unit circle. All right, so now that we have built this thing and we have all of this information on the unit circle, we want to use this unit circle to find solutions to problems. So I might ask you questions about the height at a particular position, or the coordinates, the horizontal distance at a particular position. I might give you a height that you're at and ask you to find the angle, either in radians or degrees, right? And the cool thing about this is now all of these problems that I'm asking you to do are already solved. The information is in the unit circle. All you have to do is know where to look on the unit circle to answer these questions. Okay, so let's get right to it. Let's take a look at a problem that you might see. So for instance, here number 1, it says, what is the height of the car on the unit circle that is at 120 degree angle of rotation? Okay, so they specifically tell us what we're finding, and I try to bold and underline that in the problems. Okay, so we're looking for the height. We know to find the height that we are going to use the sine function, and the sine function finds the y coordinate, right? So these three things are synonymous, right? Height, sine, and the y coordinate are all the same thing, right? So if you see this word height, if you see sine, if you see y coordinate, you know what they mean, okay? We're going to 120 degree angle of rotation, so this is where the ride starts. This is 0 degrees, and then we rotate around counterclockwise, and here we are at 120 degrees. All right, so remember, the height of the car is represented by the y coordinate, right, or the sine. This would be the sine of 120, but this number right here is the height, this √3/2. So there's no math to do. We just have to find the piece of information that we're looking for. It's already done for us on the unit circle. So we would say the height is equal to √3/2. And notice that they wanted us to leave our answers in exact form, so do not put this into the calculator and get a decimal approximation. Just leave the answer just like this, with a fraction and a square root. That's how we want it. Okay. In fact, if you put a decimal into MyOpenMath for these types of problems from now on, it's going to count you wrong. All right, so leave your answers in exact form. All right, let's take a look at number 2. Now this one is the horizontal distance, right? So we're not looking at the height anymore. We're looking at the horizontal distance, and horizontal distance is synonymous with cosine and the x-coordinate. Okay, so those three things, they all mean the same thing. They're going to be the same piece of information that we're looking for on the unit circle. Now the angle of rotation for this problem is 225 degrees. Okay, so I'm going to go over here and I'm going to rotate around until I get to 225, which is down here. So this is where the rider is at, and this is our x-coordinate right here. Okay, so this number, this is our horizontal distance. Okay, that represents this distance from here out to that point. Okay, so if we went to the left, it's going to be a negative value. Again, it's already solved for. There's no math to do. We've already done it. So this particular answer is going to be negative √2/2. Just like that. You might also have negative 1/√2 on your unit circle. Those two numbers are the same thing. If you put them into your calculator, you'll see the same exact decimal come out. So either one is fine. Just depends on how you solved for that side when you did your unit circle. Okay, so either one of those answers would be accepted. Okay. So let's take a look at number 3. We still have our unit circle up over here. They want to know the height, right? So we know that's a y coordinate. That's the same thing as sine. We want to know the y coordinate, or the height of a car on the unit circle, if the horizontal distance is 1/2. Okay, so let me get rid of some of this stuff here that I have on there. We want to look at the horizontal distance. So remember, horizontal distance is the x-coordinate, right? We're trying to find the y-coordinate that corresponds to an x-coordinate of 1/2. Okay, so if I'm looking at my coordinates here, the x-coordinate here is √3/2. This is √2/2. This is 1/2. Okay, so this is what we're looking for, is this point, and we're looking for the y-coordinate of that point. This has a horizontal distance of 1/2, and when we do have that horizontal distance, we get a height of √3/2. So we're going to say √3/2. Now, there is another answer that we could get as well, because there's another coordinate down here that has a horizontal distance of 1/2, and its height is -√3/2. So we're going to say √3/2 or -√3/2. Okay? So be aware of those scenarios that have more than one answer. Okay? All right, so let's take a look at number 4. It says, what is both the height and the horizontal distance of the car on the unit circle? So remember, height is our y-coordinate, horizontal distance is the x-coordinate. So we know what we're looking for on the unit circle. The angle that we're interested in is 300 degrees. And 300 degrees is located right here. So we're looking at this coordinate. The y-coordinate is -√3/2. So we'll say √3/2, that's our height, and then our horizontal distance is the x-coordinate, so that's going to be +1/2. Okay? That's all there is to it. It's literally just knowing where to look on the unit circle to answer these questions now. All right, let's try another one. It says, what is both the height and the horizontal distance of the car on the unit circle that is at a 7π/6 radian angle of rotation? So 7π/6, it's describing an angle of rotation. It's just not in degrees, right? It's in that radian form. So instead of looking at the degrees on our unit circle here, we're looking at the radian measures, which are right here. Okay, your unit circle from yesterday has them right next to the degrees. And we're going to go to 7π/6. So here's 7π/6, same thing as 210 degrees. And they want the height and the horizontal distance. Well, there they are. They're just right in the coordinate. So remember the height, that's the y-coordinate. So we're going to say the height equals -1/2. And our horizontal distance is equal to -√3/2. Right? So remember, height is the y-coordinate, horizontal distance is the x-coordinate. Okay. All right, let's do another one now. Number 6 says, if sine theta equals -√2/2, what are the possible angles of rotation? So they're kind of giving you a clue in this problem, because they're saying what are the possible angles of rotation, indicating that there could be more than one that has this sine value. Remember, sine is synonymous with y. It's also synonymous with height. Okay, so they're not going to fool us by changing up the wording here. They're looking for a position that has a height of -√2/2, and then we want to see what angle that is, right? And then specifically, they want that angle in radians. Okay, so we're going to go up here. We're going to look for a height of -√2/2. Okay, and so we're looking at a height. So we're looking at y-coordinates, right? So we're looking at these guys. So as I work my way around the circle here, there's one right here, -√2/2. And I'm going to keep going just to make sure I don't miss anything. And here's another one at -√2/2. So the angles that we're looking at, right, so we have 315, we have 225, and the radian measure is right here. So like I said, if you have your unit circle filled in from yesterday, you just answered that question. We're looking at 5π/4 and 7π/4 as the two possible angles. So we'd say 5π/4 or 7π/4. Right? And just leave your answer in radians, no decimals. Okay? All right, last one here says if cosine theta is -√3/2. Remember, cosine is the same thing as x, which is the same thing as horizontal distance. We're looking at a horizontal distance of -√3/2. So I'm going to go up here. I'm just going to reset my unit circle, and that way I don't have things distracting me here. So horizontal distance, we're looking at the x-coordinates, right? And we want a -√3/2. This is a positive √3/2 here, so we're going to go around over to this side. Here's a -√3/2 right here. Okay, so we have one, and then I'm going to keep going. Here's another one, -√3/2. So that's happening at 210 and 150. How do they want the answers? Do they want that in radians or Nope, they want this one in degrees. Okay, so we're just going to go ahead and write those two angles down, 150 and 210. So 150 degrees or 210 degrees. All right, guys, that's it. Unit circle is awesome and makes all these problems that we've been struggling with for a couple weeks now a whole lot easier. So make sure you give it a try. See if you can answer those questions. They're pretty simple. If you have any questions, let me know in the Zoom chat. All right, guys, have a great day.